Greetings guys, so this video will help you with the extension for outcome 3, graphing rational functions. So if you remember in the assignment, if you're printing it offline or if you received a copy in class, the only part that you are held accountable for are these top 4 equations, and you only need to find the vertical, horizontal, asymptotes as well as the domain and range of each. So don't worry about the bottom half, don't worry about these graphs, just worry about the top part. So what we're going to do is we're going to do number 1 together, okay? So number 1 is a rational function that you're given, 1 over 3x squared plus 3x minus 18, okay? So, and the first thing we have to do is find the domain and range, but I think it would be helpful first of all to find the vertical and horizontal asymptotes. Okay, so here's what you're given. You're given this guy right here, 1 over 3x squared plus 3x minus 18. And we're looking for the x values that would make this bottom part 0 in order to find the vertical or the location of the vertical asymptotes. So there's an easy way to do this, and then there's a slightly harder way to do this. Some of you, what you've been doing is you've been plugging in random values of x to see if the whole thing goes to 0. And then if you do that and you find that it does, then that means that's the location of a vertical asymptote. What else was I going to say? Well, there is a different way to do this, and let me just kind of go over that with you. What we can do is we can actually factor this denominator into 2 different pieces. Because this bottom is a quadratic function, if we just look at the bottom, it's quadratic because it has an x squared in it. We know there's going to be 2 different solutions that give us a 0 on the bottom. So what I can do is I can break this 3x squared plus 3x minus 18 into 2 parts. Okay? I can break it into 1 over 3x minus 6 and x plus 3. If you were to FOIL this, you would get precisely what you want up here. Now, how did I go from this step to this step? Well, it's a little complicated. But what I first did was I looked at the 3x squared and I thought to myself, what 2 things, when multiplied together, give you 3x squared? And I knew that it would be a 3x times another x is 3x squared. And then I thought to myself, what 2 things, when multiplied together, give you negative 18? And I knew that negative 6 times positive 3 gave me negative 18. Now, of course, there are other factors that give you negative 18, right? You could do like negative 18 times positive 1. But I just thought, like instinctually, that negative 6 and positive 3 would give us what we wanted. And so what I did was I wrote all those factors down, and then I tested it. I actually applied FOIL in order to make sure that I got this. Well, how is this helpful for me? Well, now I can truly see that when this equals 0 or when this equals 0, the whole thing will be 0, because 0 times anything is just 0. So what I did was I broke it into parts. I have 3x minus 6 is equal to 0, and that would mean that x is equal to 2. So in other words, if I plugged in a 2 here, I would get 0 for this side, which would make the whole thing 0, because 0 times whatever this is just 0. So I know that one of my vertical asymptotes is at x equals 2. And I know another one will be at x equals negative 3, because if you plug in a negative 3 to this piece, this part would be 0, and therefore the whole thing would be 0. So what does that mean? That means I have 2 vertical asymptotes. I have one at x equals 2. And I have another at x equals negative 3. Okay? So how does that help me determine the domain? Well, that's really easy. We can plug in anything we want for x except what? Except for 2 and negative 3. So I'm going to write that into a domain. I know that x can go from negative infinity to positive infinity, but x cannot be equal to 2 and negative 3. Okay? So here is my domain. okay? Negative infinity to positive infinity, and then x cannot be equal to 2 and negative 3. And the reason why is because we know that there's vertical asymptotes there, right? So the x can't be equal to those values. Now for the range and for the horizontal asymptotes, what you can do is you can plug in really, really large numbers for x, and if you think about it really carefully, if you plug in really, really big values for x, that means that you're going to be having 1 over some big, big, big number. So we know that 1 over a big number, it doesn't really matter what it is pretty darn close to what? 1 divided by some big number, it can be anything, it can be a million, a billion, or whatever, is a really, really small fraction, right? So in other words, it's really, really darn close to 0, right? Think about it, a half, a third, a fourth, a fifth, a sixth, a seventh, an eighth, a tenth, a 100th. You're slowly getting closer and closer and closer to 0 because that fraction is getting teenier and teenier and teenier, okay? So what does that mean? That means our horizontal asymptote is at 0. And that means that our range, consequently, would be all numbers of y, or of f of x, except for what? Except for 0. Okay? So I'll let you guys take it from here. If you have any questions, let me know. Thank you.